Azalea. Hello. She's back. All right, so let's get started with some of our multiplication flashcards. Now remember what we have learned so far. When 0 is a factor, the product is 0, right? What happens when 1 is a factor? The product is the other factor, right? So if it's 5 times 1, 1 is a factor. What's the other factor? A 5. So that's your answer, 5. All right, and then what happens when 10 is a factor? 10.
It's the same number, but you add a 0.
Right, you look at the other factor and put a 0 at the end of it. So if it's 3 times 10, it's 3 with a 0 after it, which is what number? What's 30, right. Okay, so are you ready? I'm going to hold these up. All right, hold on a sec. All right, here we go. Ready? What is it?
0.
When 0 is a factor, it can be up on top, it can be up on the bottom, but anytime you see a 0 in your multiplication, answer is always 0.
1 or 10.
10, right? When 1 is a factor, the answer is the other factor.
Azalea is in here.
Oh. Sorry, Azalea.
4, 8, 10, 20. This is 10. 7, 0.
Right, look, if 10 is a factor, look at the other factor and put a 0. 5, 0, 50, yes.
It's basically counting by 5.
It is, or by 10s. Count by 5, count by 10s.
6. Under 20.
Azalea, are you trying to answer? You can't see this?
Oh, I know how to do it. You go on this side and press gallery view.
Yeah.
On the top. Which I don't even have.
You can't see me? Can you see? Who do you see?
I can only see you, but when he talks, I can see him.
Oh. That's weird. Does that happen with you, Vincent?
No, it never happens.
Like
yeah, now it is.
Like when you answer, the whole screen lights up with you?
Yeah.
Oh, I didn't know that.
That's weird.
I thought you were supposed to just all be together. Here comes Albert.
It doesn't work.
All right, don't fool around with your computer. Hold on a minute.
Oh, Albert's coming.
Yeah, Albert's coming in. There he is.
Hey, Albert.
Here he is. Hi, Albert. There he is. Are you here? Are you present and accounted for?
That's the screen going out in that.
We've been trying to just get it in a spot where they want it. All ready to go, Albert? Do you hear me? No, I don't hear him.
Is he on mute?
Not on my end, he's not. Can you hear me, Albert? There. Hi, Albert.
Hi.
How are you doing?
Good.
Good. Okay, we're practicing some of our math facts, and we were discussing how we need to remember some clues in our multiplication facts. So remember, when 0 is a factor, the product equals 0, right? Then when 1 is a factor, the product is the other factor. What happens when 10 is a factor? The answer is that other factor with the 0 after it, right? Okay, so can you guys see each other? Or just me right now?
I can see everyone.
You can see
I can
everybody?
see Azalea.
Okay, so you can see everybody. Good. All right. So here, we're going to continue with these. Ready? This one is what? 120.
40. 7. 5. 9.
90.
3.
Can you see these, Albert?
3.
Yeah.
2. 9.
9.
1. 16. 18. 1. No, 2.
2.
10. 11. 100.
100. Remember, when 10 is a factor, look at the other number, put a 0 at the end. 100. All right, good job there. Okay, so now that we have 3 of you here, we can go along with our game. Okay, Vincent, remember, don't do that. I'm going to call out some combinations. You have to be the first one to answer correctly for the point. Are you ready? 9 plus 4.
15.
No, 9 plus 4. 13. Okay, 12 minus 4.
8.
Oh, that was a tie between Azalea and Albert.
I didn't hear anything.
16 minus 9.
8.
No,
7.
7. 8 plus 7.
17.
No,
18.
8 plus 7. 15. 14 minus 5.
9.
Yes. 11 minus 4.
7.
Yes. 5 plus 8.
13.
13. 13 minus 7?
6.
Yes. 15 minus 9.
6.
Yes. 14 minus 6.
8.
Yes. 8. Okay. I think Azalea won that round. Good job. I know some of us may have had a little trouble hearing all of those, but that's okay. Okay, so I want to direct your attention to the chalkboard. Do we see the chalkboard? Whoops. Wow, that took a long while for me to realize that. Okay, so we talked about what perimeter means. Who remembers what perimeter is talking about? Vincent?
Talks about how long the sides are.
Right, it's the measurement around the object. So if we have a triangle, we're going to add together all sides, the measurements of all 3 sides. The triangle has 3 sides, so they each have a measure. Like if you measured, let's say that one was 3 inches, that one was 3 inches, and that side was 2 inches. What is the perimeter? We would add all the numbers together. So what is 3 plus 3 plus 2?
15.
8, right. So the perimeter of this triangle is 8 inches, okay? Because they were 8 inches for each side. How about this rectangle?
20.
Okay, so in a rectangle, we remember that there are 2 longer sides that are the same and 2 smaller sides that are the same. And remember how we talked about different ways we can go about adding up those numbers to find the perimeter? Okay, look at here. A long side plus a short side. 7 plus 3 equals 10. That means these also equal 10. And what is 10 plus 10? 20. Or sometimes we want to add the long sides together first and then the short sides together. What is 7 plus 7?
14.
And 3 plus 3?
6.
And then you add those together and you get 20. Right, you're going to get the same answer. Or another way is just to go around the shape one number at a time. 7 plus 3 equals 10 plus 7 equals
17.
17 plus 3 equals
20.
So any way you choose to do that, if you're adding correctly, you'll get the same answer. So what are we finding when we add together all sides of a shape? We are finding the, what's that word called? Perimeter. The distance around. Okay, Vincent, can you get back to your regular screen? Because each time we play around doing different things with our computers, we're causing distractions. Okay, so what you're going to be working on today in your workbooks is pages 257 and 258. Now, Albert, I know that you don't have yours yet, but this is what it's going to look like.
Okay.
You're going to be doing a whole bunch of different activities, but look what I see in there. Perimeter. You're going to be finding some perimeters of shapes. You're also going to be writing products. That means you are what? Multiplying. Just like we were practicing with. You'll also be dividing. So let's go back to the chalkboard real quick. Do you see this right here? This is a division problem. Division problems can be written 2 ways. This is one way, but it also can be written this way, and it means the same thing. 45 divided by 5 equals, and the answer would go on top of that house. 45 divided by 5 equals. Now, we have already talked about what we have learned about time and the clock and how to count the minutes around the clock is going to help us with our division by 5 problems. Okay? So since each of these numbers, as we count minutes around the clock, we count by 5s, that can help us with any of our division problems when they're divided by 5. All you have to think of are how you count the minutes. So let's take that one. 45 divided by 5. Which number on the clock stands for 45 minutes?
10.
The 9, right? Look, 5, 10, 15, 20, 25, 30, 35, 40, 45. So look, when we divide by 5, think of the clock. in how we count the minutes, because the number on the clock that means these minutes is the answer to the division by fives. Okay? So because 9 is the number that stands for 45 minutes, 45 divided by 5 equals 9. Do you understand? Okay. What does how many minutes does the 4 represent?
20.
20. So that means 20 divided by 5 equals
4.
4. Very good. How many minutes does the 8 represent?
40.
Good. So 40 divided by 5 equals
8.
8. Very good. The 3 stands for how many minutes?
15.
Good. So 15 divided by 5 equals
3.
3. So you can use your knowledge of what you have already learned about telling the time to help you with your division and multiplication with the fives. Okay? That's a pretty cool trick, I think. All right, so let's see, what else will you be doing on here? A little bit of work with your Roman numerals. Remember, if you have trouble with your Roman numerals or any of your other combinations and measures and things, you have those in your seat work folders. So Albert, all of that stuff is included with whoever's going to come and pick up your things at school, okay? All right, so do you have any questions for me?
No. No.
No questions. Okay, Vincent?
Albert, the picture doing that same thing. Albert, then there's gonna continue.
Yeah. Okay, listen, if we were at school in the classroom and you were twirling around in your chairs, would that be acceptable?
No.
No. We have to try not to behave ourselves at home when we're trying to do our school lessons the way that we wouldn't be able to do it in the classroom, okay? Because it really gets distracting. All right, I will see you guys later.
Bye.